Let's do another example where we're going to find a Taylor series for 5 over x centered at c equal 1. It's going to be a lot easier than our previous example, or at least it better be. So what we need to do is we need to find the first few derivatives. I'm going to go ahead and write this instead as (5x to the negative 1). So my first derivative is negative 5x to the negative 2. My second derivative is 5 times 2 x to the negative 3. Third derivative is 5 times, or negative 5 times 2 times 3 times x to the negative 4. My fourth derivative is positive 5 times 2 times 3 times 4 x to the negative 5. So one of the things you notice here is that 5 over x, that 5 is actually kind of annoying. It's kind of in the way. So what you really could do is you could find a Taylor series for like 1 over x and then multiply that thing by 5 and you'd be way better off. But that's not what we have here. It would be the same idea, but I'd like to do it this way, and then we can maybe talk about the other way depending on how much board space we have. So maybe we can stop here. Maybe we can stop here. So if I plug in 1 clearly, you know, anywhere I see an x, if I replace it with a 1, it's just like the x isn't there. So you end up with 5, negative 5, 5 times 2, negative 5 times 2 times 3, 5 times 2 times 3 times 4. So the first thing I notice, so let's start writing down what we notice. It's really great if you start writing down the things that you notice. The first thing I notice is that no matter what, 5's in front, right? No matter what, I always have a 5. So it's negative for the first, the third, and it looks like the fifth derivative, right? Each time I'm going to swap. So it's negative for odd derivatives. So really odd, just odd terms. All right, and then I noticed that 4, 4, 3, 3, 2, 2, 1, that's like a 1. So it looks like I have like a factorial thing going on, right? I have 3 things. I have 5 in the front. So it looks like f sub n at c has a 5 in the front. It's negative if n is odd. So that tells me I can write it as negative 1 to the n, because if n is even, those will cancel. If it's odd, it'll remain negative. And then it looks like I have an n factorial here multiplied there, because this would be like 0 factorial. 1 factorial, that's 2 factorial. That right there is 3 factorial, and that right there is 4 factorial. So it looks like I have, this is my pattern, but remember that with the Taylor series you need fn at c divided by n factorial, so those are just going to cancel. So we get 5 times negative 1 to the n, at which point I can then say, okay, well, my Taylor series then has to be n equals 0 to infinity, 5 times negative 1 to the n times x minus 1 to the n. And that kind of makes sense. The reason that makes sense is because by that substitution method, 5 over 1 plus x is n equals 0, 5 times negative 1 to the x to the n. So that's 5 times negative x to the n. Okay, but I know that this is 1 minus negative x. And I know what the geometric series looks like because the geometric series of a over 1 minus r is a times r to the n equals 0 to infinity. So that's just 5 times negative x to the n, which is what we had here, right? It's the same idea. Because I replace x with 1 plus x, so that can't. So the idea is that you can use what you know about geometric series to work your way back if you wanted to, but that's really the answer they're looking for. And this was just kind of a self-check to make sure we were doing it right.